So we're going to talk about classification problems now. Classification task, the goal is to determine which class an observation belongs to. We're going to focus first on binary classification tasks, which means there are just two classes. In this instance, you can think of the possible labels as being yes and no. Since we're dealing with mathematical things, it helps to have numbers. So we'll often code yes as 1 and no as 0. For example, we might be looking at online purchases. We might know the zip code, the purchase time, and the purchase amount of an online purchase, and we might need to determine whether or not the purchase was fraudulent. So our output could be 1 if the purchase is fraudulent, and 0 if not. When our algorithms work on a data set, it is important that each feature, each measurement in the features be converted to a real number. In the past, we used one-hot encoding to accomplish this. When we work with a data set that has n features, we can think of each observation as a vector in the vector space Rn. We'll talk more about what that means in another video. Our goal here is to develop some geometric intuition about how classification problems look. Unfortunately, we're limited in what we can visualize. We can really only visualize two-dimensional vector spaces. And our machine learning problems typically have a very large number of features. So we will be using plots of two variables at a time to give us some information, but we need to realize that this picture is limited. If we do this over and over again and we study some more mathematics, sometimes we can develop some geometric intuition about higher dimensional spaces. The goal of a classification algorithm is to use training data to produce decision regions, dividing the space Rn into pieces where all observations should be in the same class. And the curves that separate the regions are called decision boundaries. So here's an example of a decision boundary, decision regions, and original data. You can see here there are two features and we're trying to predict 0 or 1 as the classes. You have the original data, and the decision regions tell you where you would predict new observations based on their features. So if a new observation comes in on this side in this decision region, the prediction would be 1. If it comes in on this side, the prediction would be 0. And in this case, there is a dividing line, which is the decision boundary, separates into two decision regions.